Let's learn about Python tuples. Tuples are immutable ordered sequences. Here's an example. My underscore tuple is assigned a tuple containing the integer 1, integer 2, integer 3, the string hello, and the floating point number 5.5. So what exactly are tuples? Let's explore their characteristics and how to create them. Tuples have 4 key characteristics. First, they are immutable, meaning they cannot be changed after creation. Second, they are ordered collections of items, maintaining a specific sequence. Third, they are zero-indexed, just like lists, meaning the first item is at index 0. And fourth, they can hold mixed data types, such as integers, strings, and floats, all in the same tuple. Now let's see how to create tuples. You can create a tuple using parentheses. For example, colors is assigned a tuple containing the strings red, green, and blue. Another way is to use the tuple constructor. For example, numbers is assigned a tuple constructed from the list containing the integers 1, 2, and 3. Note that a single item tuple needs a comma after the item inside the parentheses. For example, single is assigned a tuple containing the integer 42. Let's see how we can access tuple elements. We can use indexing and slicing. Fruits is assigned a tuple containing the strings apple, banana, cherry, date, and elderberry. Accessing an element by its index, first underscore fruit will be fruits at index 0, which is apple. Last underscore fruit will be fruits at index -1, which is elderberry. When we slice the tuple, middle underscore fruits becomes fruits from index 1 up to, but not including index 4, which results in a tuple containing banana, cherry, and date. So the output shows that first underscore fruit is apple, last underscore fruit is elderberry, and middle underscore fruits is a tuple containing banana, cherry, and date. Let's explore common tuple operations like concatenation, repetition, membership testing, and length. Tuple 1 is assigned a tuple containing the integers 1, 2, and 3. Tuple 2 is assigned a tuple containing the integers 4, 5, and 6. Concatenation with the plus operator, combined becomes tuple 1 plus tuple 2, resulting in a new tuple, 1, 2, 3, 4, 5, 6. Repetition with the asterisk operator, repeated becomes tuple 1 multiplied by 3, resulting in a new tuple, 1, 2, 3, 1, 2, 3, 1, 2, 3. Now, consider the membership and length. Planets is assigned a tuple containing the strings Mercury, Venus, and Earth. The expression, Earth in planets evaluates to true. The expression, Pluto in planets evaluates to false. The length of planets is obtained by len of planets and stored in the variable count. Thus the value of count is 3. If data is assigned a tuple containing the integers 1, 2, 3, 2, 1, then data.count of 1 returns 2, indicating that the integer 1 appears twice in the tuple. One of the most important features of tuple is that tuples cannot be modified after creation. Colors is assigned a tuple containing the strings red, green, and blue. If you try to modify a tuple using indexing, for example, by assigning colors at index 0 to purple, it will raise a type error. As a result, you will get a type error saying that the tuple object does not support item assignment. So, how do you work around this? One way is to convert the tuple to a list, modify the list, and then convert it back to a tuple. First, colors underscore list is assigned the list version of the colors tuple. Then, colors underscore list at index 0 is assigned the value purple. Finally, new underscore colors is assigned a tuple created from colors underscore list. Now, new underscore colors will be a new tuple containing purple, green, and blue. Tuple unpacking is a powerful feature in Python. Let's explore basic and extended tuple unpacking. RGB underscore values is assigned a tuple containing the integers 255, 128, and 0. To unpack this tuple into variables, You can assign red, green, and blue equal to RGB_ values. Now red will be 255, green will be 128, and blue will be 0. Consider extended unpacking. Numbers is assigned a tuple containing the integers 1, 2, 3, 4, and 5. Unpacking with the asterisk operator, first, second, and rest, is assigned to numbers. First will be 1, second will be 2, and rest will be a list containing 3, 4, and 5. To get the first and last elements, head, middle, and tail is assigned to numbers. Head will be 1, middle will be a list containing 2, 3, and 4, and tail will be 5. Tuples have only two built-in methods. First, the count method. It returns the number of occurrences of a value in the tuple. For example, if data is a tuple containing the integers 1, 2, 3, 2, 1, 4, and 1, then count _of ones becomes data.count of 1, which equals 3. Second, the index method. It returns the index of the first occurrence of a value. For example, if pets is a tuple containing the strings dog, cat, bird, and fish, then cat_position becomes pets.index of cat, which equals 1. The index method can also find a value within a specific range of indices. For example, if numbers is a tuple containing the integers 10, 20, 30, 20, and 40, then second_20 becomes numbers.index of 20, starting from index 2. This will return 3 because the second occurrence of 20 is at index 3. So tuples have only these two methods by design, keeping them simple and lightweight. For comparison, lists have many more methods like append, insert, extend, remove, pop, clear, sort, and reverse. Let's compare tuples with lists in Python. In terms of syntax, tuples use parentheses while lists use square brackets. Regarding mutability, tuples are immutable, meaning they cannot be changed after creation, whereas lists are mutable, meaning they can be modified. In terms of methods, tuples have only count and index methods, while lists have many methods like append, pop, and sort. For performance, tuples are slightly faster for iteration, while lists are slower for iteration but more flexible. As for use cases, tuples are suitable for fixed collections that should not change, while lists are used for collections that need to be modified. Let's discuss practical use cases for tuples. One common use case is returning multiple values from a function. Define a function called get_dimensions that returns 1920, 1080. To unpack the return tuple, you can write width, height equals get_dimensions. Now, width will be 1920 and height will be 1080. Tuples can also be used as dictionary keys because they are immutable. The locations dictionary maps tuples of coordinates to city names. The coordinates 40.7128, -74.0060 is mapped to New York, and the coordinates 34.0522, -118.2437 is mapped to Los Angeles. We can access the dictionary using the coordinate to get the city. Here are some best practices for using tuples. First, use tuples for data that should not change throughout your program. For example, months can be a tuple containing the strings Jan, February, Mar, April, May, and June. Second, use name tuples for improved readability when working with structured data. You can import nametuple from the Collections module. Then define a point name tuple with fields X and Y. Third, prefer tuples over lists when passing immutable data as function arguments or returns. If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.